everyone, and welcome to lesson 10.3. Today we are going to talk about chords in a circle. So a reminder, a chord is a segment that has two endpoints on the circle. So if we look at this circle right here, segment AB is a chord. Now if we talk about the extending line through that, that's when we talk about a secant. And we'll get more into secants in later lessons, but that's the actual line portion versus the chord, which is just a segment. Now, there are many theorems that deal with our chords in our circle. The first being if we have two chords in a circle that are congruent to each other, so they are equal in measure, then their central angles are also going to be congruent to each other. So if we look here, for instance, if I tell you WX is congruent to ZY, we also know that angle WMX and angle ZMY are going to be congruent because those chords are congruent. Our second theorem says in a circle, if a radius or a diameter is perpendicular to a chord, then it's going to bisect that chord. So notice here we have a diameter that is perpendicular, so we're creating a right angle with chord CB. So we have that right angle there. It's bisecting CD congruent to DB. Our next theorem states that if we have two arcs in a circle that are congruent, then their chords are also going to be congruent. So if we are given that arc AB is congruent to arc CD, we know that the segments AB and CD, those two chords, will also be congruent to each other. And then in our last one, in a circle or congruent circles, two chords are congruent if and only if they are equidistant, so the same distance from the center. So PQ is going to be congruent to RS because we're noticing here that AO and OB are congruent, aka the same distance. And that's going to go the other way as well. If I know that PQ and RS are congruent, I know that OB and OA are congruent because they're the same distance then from the center of the circle. Now, on the next page, we see a couple of examples to start working through. So example 1 says that in our circle P, our radius is 41 and P to R is 9. So a radius would be something like P to Q or P to S. And again, they are telling us that that's 41. And we want to find the following. So the first is the measure from Q to R. Well, given that right angle, that perpendicular situation, we know we can use Pythagorean theorem to help us solve for our missing side length x, right? Subtract the 9 squared from both sides, we get 1600, and then square root to get our final answer of 40. So right now, we know that Q to R is 40. Well, one of our theorems on the last page said that if we have this right angle happening from our center to that chord, right, we know that that chord is getting bisected. So if we then want the measure all the way from Q to S, we know that that's going to actually be 80 because both pieces, Q to R and R to S, are 40. So the whole chord would have to be 80. In our next example, we are given a circle O, which has a radius of 13. And again, we are given it is perpendicular to that chord. So a reminder, that means our chord, which they're telling us is 24 inches long, would have to be bisected if we want just these little individuals because of that right angle. So these would both be 12 and 12. And again, they gave us that our radius this time, so C to O, is 13. And they want us to find a couple of different things. Now, one thing they're also telling us is that the measure from C to D is 134. And if we only want C to B, we know that that perpendicular piece is going to bisect this. So we could take 134, divide it by 2 to get what just arc C to D measures. And then to find O to X, aka this distance from the center to our chord, again, we know that part of the chord, if we cut it in half, is 12. Our radius, aka the hypotenuse, given that setup, is 13. So we can set up, again, Pythagorean theorem to help us solve. So 13 squared minus 12 squared is 25. And then we can square root to just get that value of x. One more example with a similar setup. This time we have a chord 16 centimeters from the center. So TV is 16 centimeters from the center. Radius RU is perpendicular to that chord and TV, and we know that TV is 22 centimeters long. So again, this whole thing is 22, which means each little piece would be 11 and 11. Oops. I'm drawing very nicely. Now from there, if we want to, again, start off, they gave us the whole arc here. T to V is 110. We can cut that in half then to just find U to V. And then if we're looking for R to S, the radius, not RS, the radius of this circle. Okay, we know that we can draw in a radius here or from T to R, and that would be the hypotenuse of this. So we have R here, we have 16 and we have 11. So we can use Pythagorean theorem to help us find that radius value. So R squared equals 16 squared plus 11 squared. So we add those two together, we get 377, square root to get the radius value of 19.4. All right, down below we have one for you to try. All right, they are giving you the length of a chord is 8 from the center. The radius is 17. They want you to solve eventually for the whole chord. So find value of x first and then the whole chord. All right, on our last page, a couple more theorems here. This one is telling us that LK and IJ are congruent, which we know then means that their central angles must be congruent. So if angle IQJ is 58 degrees, we know that the other central angle must be as well, and then that arc that it opens up onto would be the same measure of 58. You then are going to try the next example. You are given that the chords are congruent, and you are finding the measure of angle IQF. Down in example 5, we are given circle G, CU and AS are congruent, and we want to find the length of A to S. Well, if we look at C to U, if we look at C to U, it's getting bisected, and C to O is 18, which means O to U is 18. And our entire chord then would be double that, 36, right? 18 plus 18. Well, they're telling us in the given information that CU is congruent to AS. So if C to U is 36, so is A to S. Over here in example 6, this time they are asking us for the radius of this circle. Okay, well, if we look at this given info, okay, again, we know that these are congruent, including AR and RS to what CO and OU are. So we know that A to R is 18. We are also given that G to R is 27. And then finally, we can draw in the radius as the hypotenuse of our triangle. So R squared is going to equal 18 squared plus 27 squared. Now, 18 squared plus 27 squared is 1,053. And after we square root, we get our radius to be about 32.4. There are two final examples for you to try. In the first one, you are finding the length of R to S. And the second one, very similar to the one up above, you are finding the radius. Thanks everyone for watching. We'll work more with these in class.